Hello branch, this is Mohit and I would like to give demo of the project that I made as a part of take-home assignment for the role of intern at branch. So let's get started. So first I would like to convey you the features that I have implemented in the project. So let's go through it. So the text that is marked as green are the features that I've implemented in the project, as well as all the additional features that I've implemented are listed here. So I will implement the feature to allow the team of agents to respond to messages where I implemented this as all the requests that are being sent by users are populated in a table based on their priorities and creation time, and the multiple agents can log in at same time on different machines, and they can select a particular chat to resolve select a particular query to resolve from the list of the queries that I have that is visible on the screen. And I have migrated the data from the CSV files that have been provided to me to the databases. Also, although I have not hosted the app somewhere, but I have dockerized the application so it can be easily run with a single command, docker compose up, that is. And I have figured out a scheme so that agents do not work on the same request at the same time. Multiple agents do not work at the same request at the same time. So implemented a mutual exclusion thing here. So only one agent will be solving a request at a time, and they can divide work among themselves in a way that all the chats are listed in the priority order. So every agent can select any one chat at a time, and they can resolve that chat. Also, I have implemented a notification functionality. That means that whenever a user submits a request, then all the agents will get notified that a new chat has been submitted by any user, and you should go and look it up. So what the user wants and what are his issues. And also made the agent UI and customer facing UI both by using socket.io to implement the real-time functionalities, and also implemented ways to give notification to users out of his multiple chats which chat has received new messages as well. Also, instead of implementing the search functionality, I was actually implementing the search functionality in the table, but due to some issues I have not completed it yet. It's in working. It's a work in progress. Although I've implemented a table where all the users can be all the requests can be seen in a tabular form, and those can be paginated depending on the I implemented pagination there as well, and the agents can select a particular chat to resolve, and maybe deselect chat. They can view all the requests that has been posted by users. They can select a particular chat to resolve. So that's the way how that works. And also I have implemented additional functionalities such as creation of requests by the users. The user can create a request and select particular issues which will have a priority waiting on which have a weight on them, so which will be used to assign priorities to those requests. And also I have implemented the mark as resolved functionality where the user or agent can mark a chat as resolved, and in that case the resolved chat the chat which has been marked as resolved will be as read only, and new message cannot be added to those chats. Also implemented pagination in the all the request table which contains all the requests that has been submitted by users, so that if let's say we have thousands of requests, so the database so the front end doesn't fetch all the requests at once, so it fetches only limited particular amount of requests that has been set, that can be set in the table as well, the amount of rows you want to fetch at once in one page. So I implemented that thing, and also implemented real-time online status. That means that whenever you are chatting with somebody, be it agent or another customer, you can see whether he's online or offline, and that's the functionality that I have included. Also I have added clear instructions on how to set up this system set up this application on your system, and I have dockerized it, so there's no need to worry about that. So let's go through so this is the GitHub repo. I have around 60 commits in last 5 days, so you can see all the commit history here. Also I've briefed about the features here as well, so you can check this out. And also I've I've given the setup instructions of the application on local machine. You only require two things, that is Git and Docker, or maybe only Docker, because you can just download zip file of the Git repo. So you need to clone it, you need to cd into the branch. You can just run docker compose up, which will do the DB migration of the MySQL DB, and to migrate data to the MongoDB you need to run this command. So that's it. With these four commands you can just run application on your local machine with ease. So I would like to discuss the architecture that I implemented in this project. So this is the architecture. We have a user, we have a customer agent. They are connected to two servers basically. I will patent these two servers because they can be scaled independently this way, as this WebSocket server is a stateful server, while the application server is a stateless server. And so by separating out the functionalities into two different servers, these servers can be scaled out, can be scaled very easily. Although currently I have not done the scaling part here. I have only made one WebSocket server and one application server, and stored the sessions in this WebSocket server in memory cache, or in memory hash map, I would say. In production we will use Redis adapter here, which will provide orchestration between different WebSocket server, between the sessions and states. For example, let's say we have two users here. We have two clients here, which are connected to different web servers. Client 1 is connected to this WebSocket server 1. Client 2 is connected to WebSocket server 3, and client 1 is connected to WebSocket server 1. So if client 1 want to send a message to client 2, he will be needed to get the room in which the client 2 resides and emit the message there. So Redis adapter here will provide the orchestration process of intercommunication between two different WebSocket servers. So this is the architecture that we will follow in production. Currently I haven't implemented this. Also I have used two databases. One is MySQL and one is MongoDB. MongoDB primarily is used for storing the chats, because as per my research, as I have done, the research I have done shows that most of the current application uses MongoDB or any other NoSQL database for chats, because it has fast random access as compared to relational DB. When the chats get very large, so it will incur an overhead when we want to do a random access from relational DB. For example, in search functionality and other functionalities that we may implement in the future. And in relational DB, I have stored all the relational data that I have. So this is the current architecture that I have implemented. Also, we can implement an application API gateway, which will act as a reverse proxy and rate limiting thing, but currently I have not implemented it, among other things. So I would like to give a brief about it. Let's close this as well. About the code. So I have dockerized the project. You can find our Docker compose file here. So we have total of 5 containers. One is the front end one is the front end container, which containing a React app. Another is app server, which is a simple HTTP server serving the API request, HTTP request, get, post, etc. And another one is socket server, which is used for real-time communication. And other two are MySQL DB and MongoDB. I use a health check functionality here because we will be needing to migrate the DB here. I found it hard to implement a migration thing for MongoDB. So I've just given a command which can be used to migrate the DB. So in the front end, as you can see, I have used React and Socket.io for the real-time communication, and Axios for fetching get and for making API requests. So these are all the things that I've used in the front end. We have backend. We have in the backend, in the application server, I have used Mongo's ODM, SQL's ORM for talking to SQL server, and Mongo's ODM for talking to MongoDB server, and Node Express for making the backend, and Socket.io for real-time communication. And I would like to also point out the thing that the application server and WebSocket server are also connected to one through a socket connection. and they can send pings or messages to emit messages to one another, which will be useful. For example, let's say a user has created a new chat request, and the request is the request goes to the application server, and the application server, and we also want to let all the agents know that a new message has arrived. So what we will do is we can emit a message from application server to the WebSocket server, and WebSocket server in turn will emit the message to all the agents that a new message has been arrived. So that's how it works right now. And in the WebSocket server, I've used these ODM and ORM and Node Express as socket IO. So these are the only things that I have used here. So let's see the app in working, I guess. So we are here. So currently I have two containers running. Let me close them. Okay, so currently we have no containers running, and we are in the application folder. So let's run this command, docker compose build. It will basically build the application and run the containers that are in the application. This is copying, it is building the front end. Let's wait for a second. Meanwhile, let's set up. So as you can see, the MySQL container is healthy and all the servers are up, so we can access our application. So let's get to it. The application is accessible at localhost. So this is the front page, and currently I have just populated a DB with 30 agents from which 30 agents, so that we can log in into the application through those email. I have not implemented the authentication here. It is a simple check, and we needed ID because we want to store some details in the front end as well. So for example, let's say we have agent.com. So this is the current agent. You see we have the agent.com. This is you, he is online right now. We have the current chats. We can see all the current chats that the user is resolving. We can message them as well, and this current chat is associated with the user 2926@user.com, right? He's a customer. We can view the chat here. We can mark it as resolved from here. We can see all the chat that has been resolved here, and as I have said, this chat is read only. As you can see, we cannot add new messages to we cannot add new messages here. This chat is for read only purposes, and we can see the priorities that has been assigned to this. I will just get back to it, what this toast means here. These are currently, we can see all the new requests here. This is the table that I was talking about. So these are currently all the requests based on the priority that has been assigned, and this is the dummy data that I have inserted in the table for sake of testing purposes and other purposes. So we have currently 54 requests right now, and we are viewing the first 20 requests here. This is the another 20 requests. At a time, only 20 chats are fetched from the server, right? We can view all the chats. We can change our rows per page here. Let's have set it to 100, so all the chats show up at once. Let's say let's say I want to see only 5 chats at once, so this shows up. Okay, now let's try to resolve one chat. Let me first show you the agent thing. Let's say I have an agent name 213@user.com. So for the user, he's a current user. As you can see here, he have a chat that he may have added this chat to get it resolved, but currently no agent has accepted the chat, so that's why we cannot see any agent here, right? For the resolved chat, we have this chat that has been resolved in the past. As you can see, this is the same chat that we saw in the agent mode of the app, and this is the same chat here that has been resolved for this user. It is read only, and now we have functionality to mark it as read from here as well. Also, we can add new chat from here, right? Now, what are these issues? These are just basically we can currently I have added dummy text here, like issue having priority 1, issue having priority 2. In production, we will be adding here realistic issues, like I'm having login issues here, I'm having some loan approval issue here, I have another some issues here, and also for all these issues we will have sub issues. Like for loan approval process, I may say that I want to query about what is the process of loan approval, and for this we may have another thing here, we have some maybe sub issues here, and we can then describe our issues here. So based on these selections, we can assign a priority to the process, to the request, so that we can so that we can resolve the most urgent request first, and we can let the users with with requests that are having very low priority for some later time, right? So let's say we want to create a chat with priority 1 and sub issue which also have a priority 1. This is the highest priority that we can set. On total, we will have 4 into 4, that is we have total 16 priorities. So let's say we have assigned here test requests with highest priority, right? Now I will also like to suggest, let's say, let me log in as agent here. Now let's say currently we have all the requests here and we do not have any new requests. Let's say, let me submit this. As you can see, as soon as I submitted, we get a notification that a new chat has been a new request has been submitted by any user. So you must go and check that what is the request. Let's say close this. Let's go to new chat section. So as you can see, this is the chat that I have just entered from the user, the 218@user.com, and let's say we want to mark it as well. We can select any chat to mark it as well, and we can select any one chat at once. We can deselect it. We may select another chat. We may select it. Let's say we select this chat to resolve. So let's solve it. Currently, I have not implemented such functionality. It's a work in progress, so that we may search for particular chats. We may also add user detail here, so we can check those. Let's resolve this chat. Now this is the chat. This is a description that we entered while making this request. So let's say user.com. So let's check. Hi, what is the issue? So as you can see, as I have sent a message from here, from agent to this user get notified that a new message has arrived, and you can check this message, and you must check this message because a new message arrived that you have not seen. Unseen message. You basically have unseen message in this chat. So when he goes, so he get here, what is the issue? So he will say, I am having issue with something, and they can basically chat. He can say something like this. You can say something like this. Now let's say this user is offline. Okay. So what happens now? Since the user is online, the messages sent from here will not get delivered right now to the user, but they will be stored in database in the backend. So as soon as the user logs in, let's say 218@user.com. Sorry. So as soon as the user logged in and he will get all the message that has been received since while he was away. So this is another functionality. We can mark this as well. Let's say We can mark this chat as resolved also. Let's say let's mark it as resolved. I marked this as resolved. Now this chat is read only. As we can see, this chat is read only now. Right now we cannot add any new messages to this chat. We can watch all the new requests as I have shown, and yep, these are all the functionalities that I have added currently. This has all. We have no new chats. We have 3 marked chats. And what about the priorities? Let's say this is the test with we added as you may remember that we have added a chat with priority 1 and sub priority 1. So here in the chips section, we in the chips we can add, for example, loan approval. In place of priority 1 we can add loan approval, and sub issue was that how to so you basically get the idea what we can add context of what the request is about, so about in this chat. So I guess that's all about the request. Let me show you the DB structure right now, right? Okay, so let me close this thing. The containers are getting close. Let me open to start. So these are the just local containers for the purpose of showing you how I have stored a DB. So yes, you can see right now we have these 2 local containers. We have now these two local containers running. Let's exit from here. Let me show you the DB structure. Okay, so see, in the MongoDB I'm just storing the chats. We have chat ID, user ID, agent ID. Currently we haven't assigned this yet because no user is resolving this chat. As soon as a user accept to request this resolve this chat, we will assign a user ID here, and which can be thereby used in other features. So these are all the chats. Currently we have only one collection, which is chats. We have stored the chats here. Okay, and in MySQL we have total 4 tables. First one is agent. We have 30. I've added 30 dummy agents right now. We can log in using these IDs into the application. I have chat progress, which means the current chat that are in progress. For example, when an agent select a chat to resolve it, this chat will show up here that the chat is currently in resolve. The resolution is in progress right now. For chats, we have all the chat requests that are being submitted by the user while creating the form, right? We have resolved by here, which means by which agent it was resolved. We have the resolved field here, which means is it resolved or not. Then we have email IDs here, which basically what I did is the CSV that I was provided in the by the branch had these IDs there, so I basically appended @user.com at the end to just satisfy my needs of the requirements for the for creating the application, right? So these are the users through which we can log in. So these are the 4 tables. We have let's show here diagrams. So users has this IDs and emails. Agents has ID and email. We have chats where the user ID is foreign key, which is connected to the users table. We have chat progress, and we have the chat ID. We have 3 foreign keys in this thing. We have chat ID, we have agent ID, and user ID. So this is the DB structure, and I think that's all. Thank you so much.